All right, we're on page 7 now. So page 7, we're going to look at the string examples. So the other video talked about how we get these equations and what to do with them. Now we're going to be looking at those examples. So the first thing I want to do is I want to talk about discussion number 11 and the first 3 Socratives that you're going to do. They really are looking at the relationship between these 3 equations. Now the basic idea is this, that if I increase the tension, it increases the speed. Increasing the speed of the wave, of that energy moving back and forth on that string, increases the frequency. Okay? So increasing tension increases speed, increase frequency. And vice versa. If I lower the tension, I lower the speed, I lower the speed, I lower the frequency. Okay. If I make the string thicker, I make a thicker mu value, I put more mass per unit length. Well, if I put a larger mu on there, that's going to decrease my speed. Decreasing my speed means decreasing my volt or my frequency. So a bigger mu value, a thicker string, lower frequency. Now, when you pluck at a different location and you change the length of the string, it still has the same mu value. You're just, if I choose half the length, there's only half the mass is vibrating then. The other half is with the other half of the string. So mu stays the same. Tension, roughly the same. You are sort of like adjusting it by pushing it down, but that's pretty negligible change in tension, hopefully. And so the speed stays the same. So when we change the length of it, all we're changing is this length. So the longer it is, the smaller the frequency. Those are inversely related. So let's do some numbers on this now. So this is where we can kind of get screwed up. So let's do an easy one first. So if I quadruple the tension and hope it does not break, what does that do to the frequency that I hear? Okay, so if I quadruple the tension, well, that's the square root of 4 is essentially what I multiplied this side by. Square root of 4 is 2, so I got to do the same thing to both sides. So if I quadruple the tension, it only doubles the speed. And if I double the speed here, well, if I multiply this side by 2, then I have to double the frequency. So by quadrupling the tension, I have doubled the frequency in that string. All right, let's try one that's a little more difficult. So let's say I take and I use a string with half the mass. Okay? Actually, let's do the other way. Let's double the mass. Let's make a thicker string that's twice as massive as the original string. You could do this by just taking 2 strings and wrapping them together. Okay, so I have 2 times the mass. What does that do to the fundamental frequency, or to the frequency? All right, so if I double the mass, that doubles the mu value. If I double the mu value, I've essentially divided this side of the equation by the square root of 2. So I've divided this by the square root of 2. Dividing the velocity by the square root of 2 means that I've divided the frequency by the square root of 2. All right, so that was a little tougher, but the discussion and the Socratives get at this idea of what is that relationship and how does it translate through that group of equations. All right, let's move on to the example question on this page. So the example question has a piano tuner stretches a steel piano wire with a tension of 800 newtons. The wire is 0.4 meters long and has a mass of 3 grams. What is the frequency of the fundamental mode? Fundamental mode, they're telling me the N value there is 1 by telling me the fundamental mode. And what is the number of the highest harmonic? So what N value could be heard by a person who is capable of hearing frequencies up to 10,000 hertz? That poor person has lost a lot of hearing. All right, so first thing we want to do is we want to identify some information. So they told me the tension was 800 newtons, they told me the length was 0.4, and they told me the mass was 3 grams. Yeah, I know what you're thinking. You got to change that to kilograms, Mr. Foster. All right, we changed it to kilograms. They also said fundamental mode, which told me the N value was 1. Okay, and they want me to figure out the frequency. All right, so I say, all right, I need to find frequency for a oscillating string, so I use my frequency equation, and N was 1, so we'll just write out the whole equation. And N is 1, L is 0.4, but they don't give me the speed. Okay, so I'll have to find the speed. Oh, I can use this equation. Okay, so the speed is equal to the square root of tension divided by mu. They gave me the tension, it was 800 newtons, but they did not tell me the linear mass density or the mu value. So what I'm going to have to do, I'm going to have to use that equation. Okay, so my mu value is equal to m divided by L. Now we got it. So now we can do m divided by L, substitute in for mu, do square root of t over mu, substitute in for v. Make sure you don't forget that tension and period are different. And you don't just go, oh, it's 1 over 800 is the frequency, because 1 over t is frequency. Be careful about that. So put this all together here. So F1 is going to be 1 times v, which is the square root of tension, divided by mu, which is m over L, all divided by 2L. Plug in my numbers, see how I do. So I have the square root of 800 divided by 0.003 divided by 0.4, all divided by 2 times 0.4. Put that all in my calculator, and if I correctly type it into my calculator, I should get 408 hertz. Yes, hertz is the correct unit for frequency. Now they want to know what is the highest harmonic that a person that can only hear 10,000 hertz be able to hear. Now here's the trick for this one. So when we think about the fundamental frequency, I'm plugging in a 1 there. So F1 is equal to V over 2L. And the nth harmonic is equal to N times V over 2L. And so what you can say is, oh, the nth harmonic is just N times the first harmonic. Okay, so basically I want to figure out what is the highest harmonic for 10,000 hertz. So 10,000 hertz is going to be the nth harmonic of 408 hertz. I find N to be 24.5, and so the highest harmonic is going to be 24, because we can only have whole number increments there, because our equation is n is equal to 1, 2, 3, and so on. So the correct answer here would be n is equal to 24, because 25 would be slightly above 10,000, probably like 10,200-ish, whereas N24 is like 200 less. Okay, so there's those examples.